September 1942. Richard M. Daniel, a chemical engineer dispatched by the War Department to investigate catastrophic fuel losses in North Africa, stood in a British supply depot near Cairo, observing something that should have been impossible in a modern mechanized army. 70,000 imperial gallons of fuel departed the depot bound for frontline positions. 30,000 gallons arrived. The remaining 40,000 gallons had simply vanished, evaporated into the desert air, seeped through corroded seams, leaked from punctured containers, been abandoned when damaged beyond immediate repair. A 57% loss rate. The British quartermaster in charge reported this as a good effort, a professional accomplishment worth acknowledging. Daniel stood among the fuel containers and understood that this figure represented not operational excellence, but institutional catastrophe. The math was undeniable. For every 2 gallons the Allies managed to deliver to combat forces, 1 gallon was lost to container failure before it could be used. The British were using containers that soldiers called flimsies, thin tinplate cans with soldered seams, 4-gallon capacity, designed for permanent warehouse storage in temperate climates, completely unsuited for mechanized desert warfare. The cans buckled when stacked. They split when dropped. They leaked continuously when exposed to the temperature extremes of the North African desert, where daytime heat regularly exceeded 120 degrees Fahrenheit.
If you found this story valuable, a like helps us share more forgotten chapters of history with those who appreciate them. Subscribe if you'd like to see more. Each story we uncover matters, and your support makes it possible to keep these voices from the past alive.
And nighttime temperatures plummeted 40 to 50 degrees, creating thermal cycling that stressed metal joints beyond their design tolerances. The seams failed constantly. Sand worked its way into fuel supplies. Many of these containers were packed in pairs inside wooden cases that were later replaced by plywood and eventually cardboard, converting them into single-use disposable containers that were discarded once emptied, requiring constant replacement rather than repair. American containers were marginally better, but fundamentally flawed in their own manner. 5-gallon rectangular cans with screw caps and cork gaskets, their designs dating back to World War I, developed for stationary fuel storage in permanent installations, rather than for the demands of mobile mechanized warfare. 55-gallon drums required mechanical pumps to empty, equipment that frequently broke, got lost, or was unavailable when needed. All of this equipment had been designed for a different era, a different kind of war, a different set of operational requirements. The entire Allied logistics system, examined through Daniel's professional perspective as a chemical engineer, was hemorrhaging the one resource that powered everything, the fuel that sustained mechanized warfare across continental distances. Daniel watched fuel seep into sand. He observed soldiers struggling with containers that required wrenches, funnels, and frequently 2 people working in coordination to pour a single can of gasoline. He documented the physical toll on personnel attempting to manage fuel supplies under desert conditions. The entire Allied logistics apparatus was simultaneously starving combat forces of fuel while consuming enormous quantities of transport capacity, moving replacement containers, and resupply missions. The mathematics were catastrophic. Generals complained about fuel shortages. Quartermasters reported supply bottlenecks. Tank commanders reported inability to execute maneuvers due to insufficient fuel. No one, it seemed, fully grasped that the problem was not insufficient fuel production, but rather a fundamental failure of the containers carrying that fuel to the battlefield. Yet the solution to this problem already existed. It had existed since 1937. It was manufactured in quantity by a military that did not face this crisis. It was so effective that Allied soldiers, when they captured examples from German supply dumps, immediately recognized its superiority and hoarded them for their own use. The German Wehrmacht possessed containers that solved every problem the Allies were struggling with. Containers that seemed almost miraculous in their functionality compared to the flimsies and American cans that dominated Allied logistics. The Wehrmacht Einheitskanister, the unit canister, had been developed in 1937 by a German engineer named Vinzenz Grunvogel, working at Müller Engineering Works in Schwelm, Westphalia. The design process that produced this container reflected a fundamental difference in engineering philosophy between German and American approaches to military problems. The German military had issued detailed specifications in 1935 and 1936, opened the design to competitive tender among manufacturers, selected the most promising entries, and then conducted extensive field testing. A test series of 5,000 containers was distributed to operational troops in 1936 for evaluation under actual combat and training conditions. The troops tested the containers, reported on their performance, and engineering teams analyzed the feedback. Based on 3 years of rigorous field trials and refinement, the German military officially adopted the design on July 8, 1937, via Order AHM No. 324. Grunvogel's design incorporated principles that reflected a sophisticated understanding of the actual conditions in which fuel containers would operate. The jerry can, as Allied soldiers called it, a name whose exact origin remains debated but may derive from the term jerry applied to Germans, measured 20 liters in capacity, approximately 5.3 United States gallons. The construction used 2 stamped sheets of steel welded together along an X-shaped seam that ran across both faces of the container. This seam construction was not decorative. It was the product of calculated engineering analysis of stress patterns under field conditions. The X-shaped indentation served 3 specific and critical functions. First, structural rigidity. The crease created 4 triangular sections that were far stiffer than flat panels, preventing the container from collapsing under impact or warping under temperature stress. Second, expansion relief. Gasoline expands approximately 2 to 3% when heated by desert sun, and the indentation flexed outward to relieve internal pressure that would otherwise warp or rupture the container. Third, when fuel cooled and contracted, the indentation flexed back inward, preventing the formation of dangerous vacuum pressure that could prevent fuel from pouring or cause the container to implode under external atmospheric pressure. The interior featured a dip coat of paint to protect against corrosion from reactive compounds in fuel. The container incorporated 3 handles, 2 short handles on the sides for one-handed carrying, allowing a soldier to carry either 2 full containers or 4 empty ones, and 1 long handle across the top for 2-handed carrying or for passing containers in a chain during rapid distribution. The handles were recessed, meaning they did not protrude, allowing containers to be stacked efficiently without interference. The cap was not a screw top, which would have required separate tools and multiple people to operate, but rather a cam lever system with an internal breather pipe. A hole in the closure retainer allowed for a securing pin or wire with a lead seal, preventing tampering or accidental opening during transport. When a soldier needed to dispense fuel, he flipped the lever. The seal released. Air entered through the breather pipe, preventing the gurgling that occurred when pouring fuel from closed containers under atmospheric pressure. Fuel poured smoothly and completely. One person could empty an entire container in seconds. No funnel was required. No second person was necessary. No wrench was needed. An air chamber design even allowed the container to float if dropped into water, preserving the fuel and the container itself. German testing documented minimal losses and superior durability across extreme conditions. The container survived drops from vehicles. It survived impacts from shrapnel. It remained functional in extreme heat and in freezing cold. It could be stacked 8 containers high without deformation. It could be transported for weeks without leakage. Every design choice reflected the brutal mathematics of mobile warfare, where supply lines stretched across vast distances and fuel losses translated directly into operational capability lost. The design was classified as a German military secret. The patent was filed in 1939 but kept from public knowledge. German military planners understood the strategic value of a logistics container so superior to anything available in the world that capturing examples from German supply dumps would become more valuable to enemy forces than many items of military equipment. Allied soldiers encountering these containers understood this instinctively. After the second capture of Benghazi at the end of 1941, large numbers of these jerry cans were captured. Sufficient quantities to equip elite units such as the Long-Range Desert Group, which by early 1942 had switched entirely from the unreliable British flimsies to these captured German containers. Supply officers requested them by name. Soldiers guarded them as carefully as they guarded ammunition or water. A single jerry can was worth more than several cases of American containers, because reliability under field conditions was worth more than quantity of unreliable supply. The American response to this German superior design constitutes one of the most consequential institutional failures of the American war effort. The story of how American engineers encountered this superior solution, rejected it, and then manufactured an inferior copy reveals something profound about how organizations respond to external evidence of their own inadequacy. In the summer of 1940, samples of the German jerry can arrived at the United States Quartermaster General's office. The exact mechanism by which these samples reached American hands remains partially obscured by the incompleteness of military records. One account, documented in post-war historical records, though not fully verified in official archival sources, describes an American engineer named Paul Pleiss, who in 1939 was building a vehicle with a German colleague for a journey to India. After constructing the vehicle, they realized they lacked adequate storage containers for emergency water in remote territories. The German engineer had access to the stockpile of jerry cans at Berlin Tempelhof Airport and managed to provide Pleiss with 3 containers along with complete specifications for their manufacture. The account claims Pleiss continued to India, stored his vehicle there, and flew back to Philadelphia with 1 container and the manufacturing specifications. According to this narrative, Pleiss approached American military officials and attempted to advocate for adoption of the German design. Without a physical sample to demonstrate, he raised no interest. Realizing that words alone could not overcome institutional inertia, Pleiss later arranged to have his vehicle shipped from India to New York by roundabout transportation and sent one of his jerry cans to the War Department. This narrative, while compelling, cannot be verified in complete detail from official military archives. The bureaucracy that rejected superior solutions rarely documented its failures with precision. What is documented with certainty is that in summer 1940, samples of the German jerry can arrived at the United States Quartermaster General's office. Later in 1940, when Pleiss was in London, British officers made inquiries about the design and manufacture. Pleiss arranged for the second of his 3 jerry cans to be flown to London. The American military response was rejection. No official reason appears in surviving documentation with absolute clarity. Speculation among historians varies. Institutional inertia, the not invented here syndrome that caused organizations to dismiss external solutions, concerns about manufacturing complexity, territorial disputes between different branches of military logistics, simple bureaucratic intransigence. The War Department decided instead to continue using World War I 10-gallon cans with 2 screw closures, containers that required both a spanner and a funnel for pouring, that leaked constantly, that required multiple people to operate effectively. These were the containers already in the supply system. These were the containers that American factories knew how to manufacture. These were the containers that American military bureaucrats understood. Change was resisted. Eventually, Camp Holliard in Maryland took interest in the German design. The Quartermaster Corps Research Facility, the primary technical organization responsible for evaluating new equipment and manufacturing processes, agreed to conduct an evaluation. They measured every dimension of the German jerry can. They photographed every feature. They tested the cam lever mechanism, analyzing its stress characteristics and operational simplicity. They analyzed the steel composition and the welding technique. They understood precisely what they were examining. Then they decided to redesign it. American engineers at Camp Hollaird in late 1940 and early 1941 created their version of the jerry can. They retained the overall dimensions, 20-liter capacity, the three-handle configuration that had been specifically engineered to allow one soldier to carry either 2 full containers or 4 empty ones. They kept the X-shaped indentations pressed into both faces, though slightly simplified. They maintained the cam lever cap mechanism. To an observer examining a German jerry can and an American jerry can side by side, they would appear nearly identical. What American engineers changed was invisible from the outside. The change was in the seam construction. The German jerry can used a welded seam. 2 stamped steel halves were pressed together and then joined by electric resistance welding along the X-shaped joint. The weld was recessed below the surface, providing structural strength while being protected from external damage. This welding process was tested extensively, time-consuming to perform, and required specialized equipment, but it produced a permanent, sealed joint that could withstand thermal cycling, impact stress, and the rigors of field conditions. The American version used rolled seams. The edges of the 2 halves were simply folded together and crimped, a process faster to manufacture, requiring less specialized equipment, cheaper to produce in mass quantities. American engineers calculated that their design was slightly lighter than the German can, reducing weight from 11.5 pounds to 10 pounds. For containers holding water or other non-volatile liquids, the performance difference was negligible. For gasoline stored in the intense heat of a desert environment, subjected to constant thermal cycling and the vibration of transport, the difference became catastrophic. Richard M. Daniel, the chemical engineer who would later document the fuel crisis with professional authority, wrote with the clarity that comes from witnessing consequences firsthand. As any petroleum engineer knows, it is unsafe to store gasoline in a container with rolled seams. The crimped metal joint, flexing under temperature changes, and the impact stress of transport develops microscopic gaps, not dramatic gushing leaks, but seepage, a slow, steady loss that multiplies across thousands of containers operating simultaneously under field conditions. American engineers also removed or simplified the interior breather tube present in the German design. They eliminated the interior plastic lining that German engineers had incorporated to prevent direct contact between fuel and steel. They made other minor modifications, each one apparently rational from a manufacturing economy perspective, each one slightly degrading the container's performance under actual field conditions. Production began. Tens of thousands of American jerry cans, manufactured according to the American design specifications, were shipped to North Africa, to the Pacific, to training bases across the United States. Immediately, universally, they performed worse than the German originals that Allied soldiers had captured and were desperately trying to preserve. The leaks weren't dramatic enough to trigger immediate alarm. A wet ring around the cap, a slight smell of gasoline hanging around stacked containers, a dark stain under containers that had been sitting in the North African sun for hours. These symptoms seemed minor in isolation. Multiply them across 5,000 containers, across 10,000 containers, across the hundreds of thousands of jerry cans operating in a theater of war, and the seepage became significant. Not as catastrophic as the British flimsies with their soldered seams that failed at similar rates to the American rolled seams, but far worse than the German jerry cans, which continued performing flawlessly year after year under identical conditions. Allied logistics officers began sorting containers into 3 categories based on observed performance. German jerry cans, the captured originals that somehow remained in military supply despite being enemy equipment, were reserved for critical operations where fuel loss would be unacceptable. American jerry cans were allocated to less demanding uses where modest leakage could be tolerated. British flimsies were used for everything else, and accepted massive losses as the price of their use. The rolled seams on American containers failed identically to the soldered seams on British containers. Temperature cycling in desert heat, from more than 120 degrees Fahrenheit during the day to 60 or 70 degrees at night, created stress that metal seams manufactured without the structural integrity of welded joints could not tolerate indefinitely. Daniel's September 1942 alarm cable, dispatched to Washington with a 40% fuel loss estimate that he himself would later admit was inflated for shock value, reached military leadership at a moment when operations were already strangling on logistics shortages. His figure, whether the intentionally alarming 40% or the documented British estimates of 30% or that specific 57% case, was accurate in its essential meaning. The Allies were losing massive quantities of fuel to container failure rather than to combat consumption or legitimate operational loss. Generals complained about fuel shortages. Armor commanders reported inability to execute planned offensives because fuel allocated for operations had been consumed in transportation rather than delivered to the battlefield. Tank crews rationed fuel to preserve supplies when mathematically there should have been sufficient fuel. Supply columns were forced to carry double the normal requirements because everyone involved in logistics understood that significant portions of any shipment would not arrive at destination, would leak away, would evaporate, would simply vanish through the combined effect of 1,000 tiny failures rather than one catastrophic loss. The War Department, when it finally acknowledged the problem, did not respond by fixing American manufacturing. Instead, the response was to let the British handle it. British factories, examining the captured German designs that were performing so well in field conditions, began mass-producing faithful copies of the German original in 1943. These British jerrycans incorporated welded seams because that was what actually worked. They included the full internal breather tubes. They incorporated the proper interior plastic linings. They eliminated manufacturing shortcuts. By early 1943, 2 million British-made jerrycans, manufactured according to German design specifications, were being shipped to North Africa. By early 1944, jerrycans were being manufactured in the Middle East as well, copying the German design rather than attempting to improve upon it. These British and Middle Eastern jerrycans worked. They did not leak. They survived desert heat and European mud. They stacked properly. They poured quickly. Everything the German original had accomplished was now being manufactured by the British. American production continued, manufacturing inferior rolled seam versions alongside British welded versions, duplicating effort, competing for resources, providing logistics officers with containers of different qualities, and requiring them to make allocation decisions about which containers to use for which purposes. The jerrycan shortage that would haunt Allied logistics throughout the European campaign was not a shortage of fuel. There was fuel in rear areas. The shortage was containers, functional, reliable containers capable of storing and transporting fuel without massive losses. In August 1944, with Patton's Third Army advancing rapidly across France, lack of containers caused by losses actually limited the volume of fuel that could be delivered to combat units, even though the fuel itself was available in rear depots. Patton's advance came to an abrupt halt at Metz in early September due to fuel shortages, deteriorating weather, and increased enemy resistance. His Third Army had outrun its supply lines, and the supply lines were constrained not by fuel availability, but by container availability. The containers that should have been carrying fuel were instead sitting in supply depots, either damaged beyond immediate repair, or lost to transport mishaps, or abandoned in the field when troops needed to travel light. By October 1944, according to official logistics records, 3.5 million jerrycans were unaccounted for. They were found scattered in a trail from Normandy to the West Wall, the German defensive line forming the border of Germany. Hundreds of thousands lay in abandoned dumps and bivouacs. Thousands more had been pressed into service for non-fuel purposes, used to build sidewalks in the mud, used as chairs, used as improvised water containers, used for storage of ammunition or supplies. The jerry cans that should have been flowing forward carrying fuel instead formed scattered archaeological deposits of military logistics failure across the French countryside. The American institutional response to this crisis reveals something essential about how organizations confront evidence of their own failure. The Quartermaster Corps, the organization responsible for supply logistics, conducted an analysis in early January 1945. Their conclusion was not that the American jerry can design should be reconsidered or that manufacturing should be corrected. Their conclusion was that the requirements had changed. Not 800,000 new containers per month as previously estimated, but 1.3 million new containers per month were needed just to keep up with losses and keep the supply system functioning. The War Department doubled down on production of containers, not reallocating resources to manufacture better designs, but simply manufacturing more of the flawed design. By VE Day in May 1945, over 19 million jerry cans had been required to support United States forces in the European theater alone. Total Allied production, including British and other sources, reached approximately 21 to 22 million jerry cans of various designs. President Franklin Roosevelt, observing the statistics in November 1944, made a statement that captured the paradoxical nature of American logistics. Without these cans, it would have been impossible for our armies to cut their way across France at a lightning pace. Roosevelt was technically correct. American armies did advance at unprecedented speed across France in the summer and fall of 1944. But the statement obscures a more complex reality. The speed was purchased at the cost of manufacturing and shipping millions of jerry cans, many of them inferior designs that leaked, that required constant replacement, that consumed transport capacity. Had American engineers been willing to copy the German design completely in 1940 or 1941 when samples first arrived, the same armies might have advanced even more rapidly because more transport capacity would have been available for ammunition, food, and other supplies rather than replacement containers. The exact volume of fuel lost specifically to American rolled seam jerry cans cannot be calculated from surviving records. As Daniel noted in his 1987 article, "The Little Can That Could," little about the jerry can appears in official records. The bureaucracy that initially rejected the superior German design continued throughout the war, minimizing documentation of the problem. What is documented is the pattern. Severe Allied fuel losses in 1942 and 1943, the obvious superiority of German containers, the British manufacturing of proper welded copies by 1943, and the gradual improvement in Allied logistics as the proportion of properly designed containers in the supply system increased. Across the Atlantic, separated by an ocean and an ideological gulf, another institutional failure was simultaneously unfolding. At the same moment, American engineers were choosing to roll crimp container seams rather than properly weld them. At the same moment, military bureaucrats were deciding that the German design was unacceptable because it was German. An even more catastrophic institutional failure was crystallizing in the German High Command. Field Marshal Gerd von Rundstedt understood, on July 1, 1944, that the war was lost. The jerry can, for all its engineering superiority, was irrelevant to the fundamental problem that Germany faced. A perfect supply container meant nothing if there was no fuel to supply, no army to supply it to, no front line that could be held. The problem was not logistics failure but strategic failure, the failure of an institutional structure to hear truth from the men who could see battlefield reality. The jerry can crisis that strangled Allied logistics in 1942 and 1943 was not primarily a problem of insufficient fuel production. American refineries produced more gasoline than any nation in history. The crisis was institutional, an organization that had rejected a proven superior solution, that had manufactured an inferior copy, that had compounded the problem through decades of institutional thinking about manufacturing efficiency rather than field performance. The Quartermaster Corps responded not by reconsidering its design philosophy, but by manufacturing more of the flawed containers. The solution was mass production of mediocrity rather than adoption of excellence. But the jerry can problem, catastrophic as it was for Allied logistics, represented only part of a larger pattern of institutional failure that was simultaneously destroying German military capability from an entirely different direction. Where American institutions had rejected technical truth about container design and doubled down on inferior manufacturing, German institutions had rejected strategic truth about military possibility and doubled down on campaigns that everyone understood could not succeed. The two failures, one in logistics, one in command structure, would intersect at the moment when both institutions' assumptions collided with battlefield reality. By 1943, as British factories began producing welded seam jerry cans that worked, German Army Group Africa was being systematically destroyed in North Africa. The campaign that had seemed to offer such promise when Erwin Rommel launched his offensives against British forces had become a grinding defeat. The problem was not the lack of excellent jerry cans. Rommel had jerry cans. The German Afrika Korps had superior logistics containers. What it lacked was fuel to put in those containers, not because production was insufficient, but because the strategic situation had become untenable. The lines of supply stretching from Germany through Italy to North Africa had been severed by Allied naval and air superiority. The fuel existed in German refineries. The containers existed. They were excellent. What did not exist was any way to move that fuel across the Mediterranean to the armies fighting in Africa. Rommel, observing this reality with the same clarity that Grunvogel had brought to container engineering, understood what needed to be done. He wrote to Hitler in March 1943 that the situation in Africa was irretrievable. The supply lines were broken. The armies could not be sustained. The only rational course was withdrawal before the forces were completely destroyed. Hitler's response was fury. The supply situation would be resolved. The Luftwaffe would protect the convoys. German determination would overcome British naval power. Rommel was removed from command. The campaign continued until May 1943, when the last German forces in Africa surrendered. Over 250,000 German soldiers were captured. The equipment losses were staggering. But Rommel, in his clarity about what was actually happening on the battlefield, had committed the cardinal sin of German military institutions under Hitler. He had spoken truth about a situation the leadership did not want to hear. He had advocated for a course of action that contradicted the Führer's certainty. He had seen battlefield reality and articulated it plainly. For this, he would eventually be destroyed. The same institutional failure that manifested in the jerry can story, organizations rejecting external evidence of their own inadequacy and doubling down on flawed approaches, was simultaneously crystallizing in the German High Command. Where American institutions responded to technical failure by manufacturing more of the failed design, German institutions responded to strategic failure by committing larger forces to lost causes and removing the commanders who understood the situation accurately. The patterns became visible in the cascading sequence of events that followed D-Day on June 6, 1944. Von Rundstedt, the senior field marshal, had opposed the dispersal of German armor along the coast. He had advocated for concentrated reserves positioned inland, ready to deliver a devastating counterattack once the invasion site was confirmed. Rommel, with his experience against Allied air power in Africa, had insisted that the invasion must be stopped on the beaches themselves before the Allies could consolidate. Hitler had resolved this disagreement by keeping the two most powerful panzer divisions under his personal control, eliminating strategic flexibility from the commanders who could see what was actually happening and who could respond to changing circumstances. The delay in releasing those panzer divisions on D-Day itself, the hours of waiting while Hitler slept, while deception operations convinced the Führer that Normandy was a feint, while the critical window for counterattack closed, represented an institutional failure analogous to the rejection of the jerry can design. A decision made at the top, disconnected from reality, compounded by institutional structures that prevented those closest to the problem from taking effective action. The result was strategic catastrophe. By July 1, 1944, the facts were undeniable. The Allies had landed over 600,000 men in Normandy. They controlled the skies. They were establishing themselves with overwhelming material advantage. German casualties were running at 2,500 men per day, with replacement arriving at perhaps 1,000. The mathematics of attrition were inexorable. Von Rundstedt, having traveled to the Berghof and attempted to convince Hitler that the war was lost, having been dismissed for this honesty, picked up a telephone and spoke the words that would define him. "End the war, you idiots! What else can you do?" The institutional response was swift. Von Rundstedt was dismissed. General Günther von Kluge was appointed as his replacement. Von Kluge arrived in France confident that he could stabilize the situation, that the apparent collapse of German defensive capability was illusory, that a more forceful approach to command would achieve results that the pessimistic von Rundstedt had deemed impossible. Within days, von Kluge understood the reality. The situation was exactly as bad as von Rundstedt had described. The war was indeed lost. The only variable was how much additional destruction would occur before this truth became undeniable to everyone, including Hitler. The logistics situation in Normandy mirrored the broader strategic catastrophe. Jerry cans, German jerry cans manufactured, according to Grunvogel's design, worked perfectly. They stored fuel efficiently. They transported without leakage. They poured quickly. German logistics containers were superior in every measurable way. But superiority in container design meant nothing when the supply lines themselves were being systematically destroyed by Allied air power. Railways that should have carried supplies from Germany to France were being bombed. Roads were cratered by artillery. The French resistance, coordinated with Allied intelligence, was sabotaging transportation networks. Convoys that departed from supply depots were being attacked by fighter bombers before they could reach the front. The logistics system was being destroyed not by container failure, but by the fundamental inability of Germany to move supplies forward under conditions of Allied air superiority. The pattern repeated itself through the summer of 1944. As the Allies expanded their foothold and began the breakout from the Normandy beachhead, German forces found themselves caught between two institutional failures: the jerry can design flaw that plagued American logistics, and the strategic flaw that prevented German leadership from responding effectively to battlefield reality. American forces, despite the handicap of inferior containers that leaked fuel and required constant replacement, could afford to waste resources because American industrial production was unlimited. Every jerry can lost could be replaced. Every container that leaked could be discarded and a new one manufactured. The Red Ball Express, the audacious logistics operation that would eventually deliver 412,000 tons of supplies to Patton's advancing armies, would not be created until late August. But the principle that drove it was already visible. American institutions, for all their design flaws and manufacturing shortcuts, could overcome those flaws through sheer volume and industrial excess. German institutions, conversely, could not afford any waste. German jerry cans were superior in every way to American and British containers. They did not leak. They stacked efficiently. They required no tools to operate. But German jerry cans, no matter how perfectly engineered, could not move supplies across a landscape being systematically destroyed by Allied air power. German strategic plans assumed that surprise and initiative would provide protection. German military doctrine expected that rapid movement and tactical superiority would determine outcomes. The reality, that industrial capacity and the ability to absorb losses would determine outcomes, violated every assumption upon which German military thinking had been constructed. Field Marshal Erwin Rommel, commanding Army Group B in Normandy, understood this. He had seen it in North Africa. He had watched German armor destroyed by Allied air power. He had seen supply convoys annihilated. He had seen tactical victories rendered meaningless by the inability to sustain forces under conditions of enemy air superiority. He had advocated for peace in June 1944, suggesting that negotiations might preserve something of Germany's position before complete collapse made negotiation impossible. For this honesty, he was implicated in the July 20th assassination conspiracy. He was offered a choice: face Hitler's People's Court and execution with his family persecuted, or take poison and preserve his family's honor and safety. On October 14, 1944, he chose poison. He was 52 years old. Von Kluge, replacing von Rundstedt, reached the same conclusion. The war could not be won. Continuing to fight would only increase destruction. He wrote to Hitler urging that peace be considered. He was recalled to Berlin. On August 19, 1944, on the road back to Germany near Metz, he pulled his car to the side of the road and swallowed cyanide. He was 61 years old. The institutional pattern was unmistakable. Every senior commander who saw the truth and spoke it was destroyed. The system was optimizing for conformity rather than accuracy. Good news flowed upward through the chain of command. Bad news was filtered, softened, delayed, or blocked. Officers who reported honestly on unfavorable situations were accused of defeatism and removed by officers who reported what the leadership wanted to hear. The jerrycan shortage that plagued American logistics in 1942 and 1943 was painful, but ultimately survivable because American institutions could absorb waste. The strategic catastrophe that destroyed the German army in the West in 1944 was fatal because German institutions could not absorb honest assessment of failure. The two failures intersected at the point where both armies were fighting the same war with fundamentally different institutional capacities to sustain themselves under adverse conditions. In August 1944, as the Falaise pocket closed around German forces in Normandy, approximately 50,000 German soldiers were trapped in an area covering perhaps 40 kilometers. The roads out of the pocket were being pounded by American artillery and Allied aircraft. Escape routes that had existed on August 10th were sealed by August 15th. German soldiers trapped in the shrinking perimeter experienced what American soldiers had experienced throughout the summer: the devastating effects of air superiority, the inability to move without being attacked, the slow erosion of military capability through attrition that could not be replaced. The exact number of German soldiers killed in the Falaise pocket has been disputed by historians. Estimates range from 10,000 to 15,000 killed. Another 40,000 to 50,000 were captured. Thousands more escaped, but they escaped without their vehicles, without their heavy weapons, without their equipment. The German 7th Army ceased to exist as an effective fighting force. The equipment losses were staggering. Approximately 500 tanks and assault guns destroyed in the pocket, tanks that Germany could not replace. Tank production in August 1944 was approximately 1,800 units across all types. But German tank losses in France in August alone exceeded 2,000. The arithmetic was unsustainable. Germany was losing more armor every month than it could produce. The strategic situation had been exactly as von Rundstedt had described it on July 1st. The war was lost. Continuing to fight would only increase the destruction. The mathematics could not be overcome by will, by belief, by determination, or by German superiority expressed in excellent jerrycans. German containers were perfect. German strategy was catastrophic. The institution had optimized for tactical excellence while destroying itself strategically. By September 1944, the Allies had liberated Paris. By October, they had reached the German border. The Netherlands, Belgium, and most of France had been conquered. The Wehrmacht had lost over 400,000 men in France since D-Day, killed, wounded, missing, or captured. German divisions that had fought in France were being reconstituted with replacements who had no combat experience. Supply lines that should have stretched from Germany to the Rhine were being compressed into shorter and shorter distances as German territory itself was invaded. The bombing campaign intensified. German cities burned. Dresden, Hamburg, Cologne, Berlin, and dozens of others were reduced to fields of rubble by waves of American bombers by day and British bombers by night. Hundreds of thousands of civilians died. Industrial production collapsed as factories were destroyed faster than they could be rebuilt. The transportation network that should have carried supplies to front lines was systematically dismantled. Railroad lines were cut, bridges were destroyed, roads were cratered. The logistics system that had functioned reasonably well in 1940 and 1941 was being methodically destroyed in 1944 and 1945. The jerry can, that engineering marvel of 1937, became increasingly irrelevant, not because the design was flawed, but because there was nothing to put in it. Fuel production was collapsing. Refineries were being destroyed. The oil fields in Romania that supplied much of Germany's fuel had been lost to advancing Soviet forces. The jerry can, perfectly sealed, perfectly designed to preserve whatever fuel it held, was increasingly holding nothing. American jerry cans, meanwhile, continued to leak. Rolled seams continued to fail under thermal stress and impact. American forces continued to lose fuel to container failure, continued to require millions of replacement containers, continued to accept this waste as acceptable overhead of conducting industrial warfare. Yet American forces continued to advance because American industrial capacity could replace what was lost. For every container that leaked, American factories produced a replacement. For every tank that was destroyed, American factories produced a new tank. For every soldier killed, America could field a replacement trained and equipped and ready for combat. Germany, with superior container design, with superior tank design, with engineering excellence in almost every domain of military equipment, could not replace losses. The jerry can was perfect. The Panther tank was superior to any American tank. German small arms were excellent. German military organization was sophisticated. But perfection in isolated domains could not overcome the fundamental disparity in industrial capacity. Germany was fighting not just American forces but American factories. German institutions could optimize design details, while American institutions optimized production scale. The comparison manifested itself in specific, measurable ways. American forces capturing German supply depots were amazed by the quality and organization of German logistics. The containers were superior. The documentation was meticulous. The supply system was sophisticated. Yet the depots themselves were often smaller than American depots and supplied fewer troops. American soldiers accustomed to abundance found German logistics efficient but constrained. A single American supply depot might contain more material than German forces captured in an entire region. By late 1944, the contrast had become almost surreal. German forces, fighting on their own soil, with supply lines that should have been relatively short, were increasingly starving for ammunition, fuel, and food. American forces, thousands of miles from their production centers, operating under the handicap of jerry cans that leaked, were increasingly overwhelming German positions through sheer material abundance. The Red Ball Express, the legendary truck convoy operation that would eventually deliver over 400,000 tons of supplies in 82 days, would not fully compensate for the jerry can shortage, but it demonstrated the principle that American logistics would overcome American equipment failures through mass production and ruthless exploitation of transport capacity. The mathematics of attrition in late 1944 were exactly what von Rundstedt had calculated in July. German forces were losing more men than could be replaced. German industry was producing less equipment than was being destroyed. Soviet forces were advancing from the east at a rate that suggested they would reach Berlin within months. American and British forces were advancing from the west with material advantage that no German military innovation could overcome. The war was lost, as von Rundstedt had said, and every month that continued meant additional millions dead, additional destruction of German territory, additional dismantling of German society. Yet the war continued. Hitler refused to accept reality. He surrounded himself with officers who told him what he wanted to hear, that victory was possible, that wonder weapons would change everything, that German superiority would prevail. The officers who told him the truth were removed, imprisoned, or killed. Rommel was dead by poison in October 1944. Von Kluge was dead by poison in August 1944. Von Rundstedt, recalled to command in September 1944, understood his role was to preside over catastrophe, not to prevent it. In December 1944, Hitler launched his final offensive in the West, the Battle of the Bulge through the Ardennes. Von Rundstedt opposed the operation. He thought the forces allocated were insufficient. He thought the logistical situation made sustained offensive operations impossible. The fuel did not exist to reach Antwerp, the stated objective. The Luftwaffe could not provide air support. The entire concept was strategically unsound, a gamble that could not succeed and would consume Germany's last reserves for no achievable objective. Von Rundstedt proposed a more limited attack that might achieve local success without risking everything. Hitler rejected it. The offensive would proceed as he had ordered. The operation went forward on December 16, 1944, with approximately 250,000 German soldiers and 1,400 tanks and assault guns, the last significant reserves Germany possessed. For the first few days, German forces achieved tactical surprise. American positions buckled. Entire American divisions were overrun. The situation appeared desperate for the Allies, but von Rundstedt was correct about the logistics. The operation consumed fuel at a rate that exceeded German fuel production. German tanks sat motionless on roads, out of fuel, waiting for supplies that did not arrive. American fighter bombers, once the weather cleared, attacked these immobilized concentrations of armor. German forces that had advanced 60 miles in the first week began retreating. By late January, the Bulge had collapsed. German forces were back where they had started, having lost 100,000 casualties and 800 tanks that could never be replaced. The jerry can, that perfect expression of German engineering excellence, would not have solved this problem. Even with containers so superior that fuel losses were minimal, the problem was that there was insufficient fuel to move in any container. The strategic failure overwhelmed any technical excellence. The institutional pattern that had manifested in the rejection of superior container design and the manufacturing of inferior copies now manifested in the destruction of the German state itself. German institutions, optimized for a certain kind of warfare, for a certain kind of opponent, for a certain kind of strategic situation, had become incapable of responding to a reality that contradicted their assumptions. American institutions, for all their design flaws and manufacturing compromises, had the flexibility to absorb failures and respond through overwhelming production capacity. The war in Europe would continue for another 5 months after the Battle of the Bulge collapsed. German forces would fight delaying actions across Germany itself. Cities would be reduced to rubble. Soldiers would die by the tens of thousands in battles for objectives that everyone understood had already been lost. Soviet forces advancing from the east would eventually reach Berlin. Hitler would commit suicide in his bunker on April 30, 1945. Germany would surrender unconditionally on May 8, 1945. Everything von Rundstedt had predicted came to pass. The war that he said was lost on July 1, 1944 continued for 10 months, consuming millions of lives, destroying German cities, resulting in the complete defeat and occupation of Germany. The only outcome that could have been different was the outcome that Hitler refused to permit. Peace, while it might have preserved something of Germany's position, was incompatible with the Führer's certainty that victory was still achievable through will and determination and German superiority. The men who understood this truth, Rommel, von Kluge, von Rundstedt, were destroyed by the institution that needed them most. The Jerry Can, that masterpiece of 1937 engineering, became a symbol of German institutional excellence in domains where excellence was possible and irrelevant in domains where it was most desperately needed. American Jerry Cans leaked. American strategic planning was superior. German Jerry Cans were perfect. German strategic planning was catastrophic. By May 1945, when Germany surrendered, over 19 million jerry cans had been required to support American forces in Europe alone. The jerry can shortage that had strangled American logistics in 1942 and 1943 had been overcome through overwhelming production, 22 million containers of various designs manufactured by American, British, and other sources. The post-war military specifications for jerry can design, established after the war ended, mandated welded seams, effectively abandoning the American rolled seam approach that had caused so many losses. The NATO standard 20-liter military fuel container used in military operations worldwide today is essentially the 1937 German design with minor modifications. Nearly 90 years after Vinzenz Grunvogel designed the container at Müller Engineering Works in Schwelm, Westphalia, the basic design remains unchanged because the engineering was correct. The welded seams work. The X-shaped indentations function as intended. The breather tubes operate effectively. Every design choice served a purpose. Tested under extreme conditions. Proven through years of field use. Germany created a masterpiece through necessity and engineering excellence. America initially rejected it, manufactured an inferior copy, and then eventually recognized the superiority of German design and post-war specifications, mandated faithful replication of the German original. But by the time American institutions recognized the value of what German institutions had created, the war was over. Germany was defeated. The engineers who had designed the container had witnessed the complete destruction of the nation that employed them. August 26, 1944. Lieutenant Colonel Laurent Awais of the Motor Transport Service stood in a requisitioned French chateau near Dreux, approximately 50 miles west of Paris, studying maps that showed supply lines stretching backward toward the Normandy beaches and forward toward Patton's rapidly advancing Third Army. The mathematics before him contradicted everything conventional military logistics doctrine suggested was possible. Patton's forces were consuming supplies at rates that exceeded any army in history. The front was advancing at speeds that made resupply theoretically impossible. The distance from supply depots to combat units was growing by 30 to 60 miles daily. The problem was not fuel shortage. American refineries were producing more gasoline than any nation in history. The problem was containers. The jerrycan shortage that had plagued American logistics in 1942 and 1943 had never been fully resolved. By August 1944, despite the production of millions of containers, shortages persisted. The American rolled seam jerry cans continued leaking. The British manufactured welded seam copies, which worked far better, were insufficient in quantity. The system was hemorrhaging containers faster than they could be replaced. American supply officers recognized that the fundamental problem was not that they lacked fuel, but that they lacked reliable containers to move that fuel forward. Awais and his staff conceived a solution that violated every principle of logistics efficiency that military doctrine had established. Traditional supply methods, scheduled convoys on designated routes, depots positioned at regular intervals, careful rationing of transport to match supply capacity, had all assumed that supply lines would move gradually, deliberately, conserving vehicles and fuel, minimizing waste. Patton's advance was moving so rapidly that traditional methods had become not merely inefficient, but completely inadequate. Instead of attempting to match supply delivery to Patton's speed, Awais proposed something radically different. What if they created a temporary logistics system that existed only to feed the advance, that was ruthlessly wasteful by conventional standards, that treated vehicles as disposable and speed as the only metric that mattered? The Red Ball Express was born not from military genius or logistical innovation in design, but from the recognition that American industrial capacity was so overwhelming that efficiency was actually a luxury that could be abandoned. Two parallel one-way highways, one for loaded trucks moving forward, one for empties returning. 24-hour continuous operations with headlights blazing, abandoning blackout discipline. No stopping except for fuel and mechanical failure. 5-minute convoy intervals, maintaining 35 miles per hour average speed. Mobile maintenance units every 50 miles. Military police checkpoints removing any vehicle below 25 miles per hour. The contrast with German logistics philosophy could not have been more striking. German logistics doctrine emphasized careful planning, maintenance schedules, proper procedures, conservation of resources. The Red Ball Express violated every principle. Trucks operated at mechanical failure rates approaching 30% daily. Vehicles were abandoned rather than repaired. Drivers operated on stimulants for days, hallucinating from exhaustion. No camouflage discipline. The entire operation was visible to German air reconnaissance that never came. Fuel consumption was prodigious. The operation itself consumed 300,000 gallons daily just to move supplies, more than many German armies received for all purposes. Yet the Red Ball Express worked. The mathematics that appeared impossible became routine. By August 28th, German reconnaissance units began reporting something unprecedented. Continuous vehicle columns, headlights visible for 20 kilometers, no spacing, no blackout discipline. Estimate 1,000 vehicles per hour. Americans have abandoned all military precaution. General Lieutenant Edgar Feuchinger, commanding the 21st Panzer Division, personally observed the Red Ball from concealed positions and reported to Army Group B headquarters. The enemy operates a supply system beyond our comprehension. Vehicles pass at 30-second intervals, day and night, without pause. They don't hide, don't disperse, don't follow any rules we understand. It's not military science. It's mass production applied to warfare. German military science could not comprehend the Red Ball Express because German military science was optimized for efficiency, for conservation, for careful management of scarce resources. American military science was optimized for something entirely different: the application of overwhelming industrial capacity to overcome any obstacle through sheer volume. Where German doctrine conserved vehicles, Americans assumed 20% mechanical failure and planned accordingly. Where Germans followed strict military procedure, Americans improvised continuously. Where Germans maximized the utility of each resource, Americans maximized the velocity of the entire system. The first week of the Red Ball Express delivered 89,139 tons of supplies, a daily average of 12,048 tons. The round-trip distance from supply depots to forward positions was 686 miles. The operation utilized 5,158 trucks, making an average of 1.5 trips daily. The fuel consumed by the operation itself was 300,000 gallons. German logistics specialists, when they eventually captured American documents describing the operation, dismissed the numbers as propaganda. But the numbers were real. They were accelerating, and they were made possible not by logistical brilliance, but by industrial capacity so overwhelming that waste became acceptable overhead. The Red Ball Express would eventually deliver 412,193 tons of supplies, over 2 million ton miles, in 82 days of continuous operation. The operation would consume 57 million gallons of fuel and wear out 180,000 tires. By the end, 5,000 trucks would be destroyed or abandoned, vehicles simply discarded when they became uneconomical to repair. The operation would employ 23,000 drivers, approximately 75% of them African American soldiers serving in a still segregated military, men who could not eat in white restaurants or use white facilities in much of America, but who were making history by delivering victory at 35 miles per hour. The psychological impact on German forces was devastating precisely because it violated German assumptions about how warfare should be conducted. Wehrmacht soldiers could hear American trucks all night, every night. Endless motors, endless supplies. They had 3 rounds per rifle while Americans were bringing millions of rounds. The sound itself became psychological warfare, proof that Americans possessed resources Germany could never match, that industrial capacity had become the determining factor in modern warfare, that the side with the most trucks would ultimately defeat the side with the best tactics. The Red Ball Express succeeded where the jerry-can design had failed, by embracing American institutional characteristics that German institutions despised. Waste, abundance, the willingness to discard perfectly functional equipment if newer equipment was available, the improvisation of individuals at every level of the organization, the decentralization of decision-making that allowed sergeants to make choices that would require field marshal approval in the Wehrmacht. These were the same characteristics that had produced the inferior rolled seam jerry can, the assumption that good enough was acceptable if it could be produced in sufficient quantity. Yet these same characteristics, when applied to logistics at scale, created something that German efficiency could never match. The jerry can problem had never been fully solved in the American supply system. American rolled seam containers continued leaking. British welded seam copies were superior but insufficient in quantity. Yet by September 1944, with the Red Ball Express delivering 12,500 tons daily and Patton's advance accelerating, the jerry-can shortage had become almost irrelevant. The operation was moving so much volume that losses due to container failure were absorbed within the overall system. For every container lost to leakage, 5 more were available. For every container abandoned in the field, replacements were already in production and en route. The contrast manifested itself in specific operational outcomes. In August 1944, Patton's Third Army advanced 35 miles in morning operations and another 32 miles in afternoon operations on a single day. A 67-mile advance that shattered German defensive planning, which assumed maximum 30-mile daily advances. The advance was possible because the Red Ball Express had delivered fuel to forward positions. The jerry-can shortage that would have strangled such operations 2 months earlier had been overcome not by solving the jerry-can problem, but by generating such overwhelming supply volume that the jerry-can problem became statistically insignificant. Meanwhile, in France, German forces continued to use their superior jerry-cans with perfect efficiency, achieving minimal fuel losses, stacking containers flawlessly, pouring fuel with single-person operation, demonstrating engineering excellence in every measurable dimension. Yet German forces were simultaneously starving for fuel because the supply lines themselves were being destroyed by Allied air power. The perfect container could not overcome the fundamental problem. There was insufficient fuel to put in it, and no way to move that fuel safely across territory dominated by enemy aircraft. By October 1944, the paradox had become complete. American forces, burdened with inferior jerry cans that required millions of replacements, were advancing rapidly and consolidating their position. German forces, equipped with superior jerry cans that German engineers recognized as masterpieces of design, were retreating across their own territory with insufficient supplies to sustain resistance. The jerry-can shortage that had been catastrophic in 1942 and 1943 had been overcome through American institutions' willingness to accept waste and manufacture overwhelming quantities. The fuel shortages that would eventually destroy German resistance could not be overcome through engineering excellence or logistical efficiency because the fundamental problem was strategic, not tactical. President Franklin Roosevelt, observing the statistics of the Red Ball Express in November 1944, captured this paradox in a single sentence. Without these cans, it would have been impossible for our armies to cut their way across France at a lightning pace. Roosevelt was referring to jerry cans, the containers that had frustrated American logistics planners throughout 1942 and 1943. The fact that Roosevelt was citing them as essential to American victory obscured a more complex reality. American victory was being achieved not because American jerry cans had become superior. They had not. American victory was being achieved despite inferior jerry cans, because American institutions had the capacity to overcome design flaws through overwhelming production and ruthless acceptance of waste. This principle extended far beyond jerry cans. American tank production in 1944 exceeded 2,000 units monthly. German tank production had collapsed to perhaps 500 units monthly as factories were bombed and resources were diverted. American casualty rates were absorbed because replacement soldiers were available. German casualty rates were catastrophic because replacement soldiers did not exist. American aircraft losses were replaced by new aircraft. German aircraft losses consumed trained pilots that German flight schools could no longer produce because fuel shortages prevented training flights. The Wehrmacht, observing this disparity, began to understand what it meant. Field Marshal Walter Model, commanding German forces in the West in September 1944, wrote, "If these reports are accurate, we face not a superior army but a superior civilization. They make no effort to hide because they don't fear us. They waste resources because they have infinite resources. We cannot defeat this with military tactics." Model was correct. American institutions could not manufacture jerry cans that matched German designs. But American institutions could manufacture jerry cans by the millions and absorb losses that would have paralyzed any other military. German institutions could design superior containers and achieve minimal waste, but lacked the industrial capacity to produce sufficient quantities or the supply lines to deliver what was produced. The outcome was determined not by which institution had superior design philosophy, but by which institution could sustain overwhelming volume. The post-war evaluation of the Red Ball Express by military historians and logistics specialists universally recognized the operation as decisive. Without the Red Ball Express, Patton's advance stops. Paris falls weeks later. German forces successfully establish winter defensive lines. The German army in the West survives to fight another campaign. The war lasts months longer. Hundreds of thousands more die. The outcome changes because logistics determines strategy more than tactics determines strategy. Yet the Red Ball Express succeeded not through superior design, but through the willingness to embrace American institutional characteristics: mass production, waste, decentralization, improvisation, the willingness of individuals at every level to make decisions and take actions that in the German military would require approval from senior command. These characteristics had produced the inferior jerry can. These same characteristics, when applied at scale to logistics, created something that German efficiency could never overcome. By November 1944, as rail transport began to restore conventional logistics capability and the need for the Red Ball Express diminished, the operation had achieved something remarkable. It had demonstrated that in modern industrial warfare, the side with unlimited resources could overcome any obstacle through sheer volume. The jerry can shortage that had existed in 1942 and 1943 had never been solved in terms of superior design. The American rolled seam jerry can remained inferior to the German and British welded seam designs, but the jerry can shortage had been overcome through overwhelming production. 22 million containers of various types manufactured by American, British, and other sources. By the time the jerry can shortage became truly critical, the Red Ball Express was delivering so much supply that container shortage became irrelevant. The institutional lesson was stark. German institutions could design perfect jerry cans and waste nothing and still lose because they lacked the industrial capacity to sustain warfare against an opponent with unlimited resources. American institutions could design flawed jerry cans and waste everything and still win because they possessed industrial capacity so overwhelming that waste could be absorbed as acceptable overhead. Post-war military specifications governing jerry can construction eventually mandated welded seams, effectively abandoning the American rolled seam approach that had caused so much loss in 1942 and 1943. The NATO standard 20-liter military fuel container used today, designated by specifications like MYLC-83F from 1985 and its successors, is essentially the 1937 German design with minor modifications. Nearly 90 years after Vinzenz Grunvogel designed the container, the fundamental design remains unchanged because the engineering was correct. Every detail served a purpose. Every design choice was necessary. The welded seams work. The X-shaped indentations function as intended. The breather tubes operate effectively. The triple-handle configuration allows efficient carrying and stacking. Germany created a masterpiece through necessity and engineering excellence. Germany lost the war despite that masterpiece because institutional capacity for industrial production could not match American output. Germany had superior design. America had superior capacity. In modern industrial warfare, capacity determines outcome. American engineers initially rejected the superior German design, manufactured an inferior copy, and then spent years manufacturing millions of flawed containers because changing production would have required admitting institutional failure. The American institutional response was not to adopt the superior design, but to manufacture more of the flawed design. This would have been catastrophic in isolation. But American institutions, precisely because they had the capacity to manufacture overwhelming quantities, could afford this inefficiency. The waste of millions of inferior jerry cans was acceptable because American factories could replace them. German institutions could not afford such waste. Every container mattered. Every design detail was critical. The jerry can was perfect because perfection was necessary. Yet perfection in isolated domains could not overcome the fundamental disparity in industrial capacity. Germany was fighting American factories, not just American armies. The factories producing jerry cans, trucks, ammunition, and food could generate output that no German defensive position could possibly absorb. The Red Ball Express, operating at its peak in September 1944, delivered 12,500 tons daily to Patton's advancing armies. German supply capacity in France during the same period could deliver perhaps 3,000 tons daily, and even that was frequently interrupted by Allied air attacks. The disparity was not due to German logistical inefficiency. German logistics were efficient, organized, professional. The disparity existed because Germany did not possess the industrial capacity to compete. American factories could produce more trucks than Germany possessed of all types combined. American petroleum refineries could produce more fuel than Germany's entire military consumed. Patton's famous statement about the Red Ball Express captured the fundamental reality. The truck drivers of the Red Ball Express deserved as much credit for the defeat of Germany as any combat unit. They drove through exhaustion, through mechanical failure, through weather that stopped armor. Without them, the Third Army doesn't move. Without movement, we don't win. They were black soldiers, mostly, segregated, discriminated against, denied recognition. But they won the war as surely as any rifleman. Patton was correct, but incomplete. The Red Ball Express succeeded not because of superior design or tactical brilliance, but because American industrial capacity could absorb the losses that would have paralyzed any other military. 23,000 drivers operating 6,000 trucks for 82 days consumed extraordinary quantities of resources: fuel, tires, replacement vehicles. American institutions could afford this waste. German institutions could not. The jerry can story and the Red Ball Express story together reveal something fundamental about how institutions succeed and fail in warfare. Germany optimized for efficiency. Germany designed perfect containers. Germany manufactured products of superior quality. But Germany lacked the industrial capacity to generate overwhelming quantities. American institutions optimized for output. American institutions manufactured flawed designs. American institutions accepted enormous waste. But American institutions possessed industrial capacity that could absorb waste and continue advancing. In 1937, when Vinzenz Grunvogel designed the jerry can, Germany possessed superior engineering and was building military capacity. By 1944, when the Red Ball Express rolled across France, Germany possessed superior design, but insufficient capacity. America had always possessed superior capacity, and by 1944 had also begun producing according to German design specifications. British factories manufactured faithful copies of the German original. American post-war specifications mandated welded seams. The German jerry can, which had been rejected in 1940 as unacceptable, became the NATO standard by the post-war period, proving that Germany had been correct all along, but no institution that could implement the design at scale when it mattered most. By May 1945, when Germany surrendered unconditionally, the war that von Rundstedt had said was lost on July 1st, 1944 had finally ended. Everything von Rundstedt predicted came to pass. The continued fighting had achieved nothing except to increase destruction. German cities lay in rubble. The German population was displaced and homeless. German sovereignty had been erased. German territory was divided among victorious powers. The war that should have ended in July 1944 continued for 10 months because Hitler refused to accept reality and destroyed everyone who attempted to make him hear the truth. The jerry can represented German institutional excellence in isolation. It was a perfect design with no margin for improvement. Yet it could not solve the problems German institutions faced because those problems were strategic, not technical. German strategy was catastrophic. German command structure was pathological. German leadership refused to hear voices advocating for peace while anything could still be saved. The jerry can was perfect. Germany was doomed. No engineering excellence could overcome strategic failure driven by institutional refusal to acknowledge reality. The Red Ball Express represented American institutional pragmatism applied at scale. It was wasteful by every conventional standard. It violated military doctrine. It treated vehicles as disposable. It accepted mechanical failure rates that would have been considered catastrophic in any other military. Yet it succeeded because it was compatible with American industrial capacity. America could afford to waste millions of jerry cans because American factories could produce millions more. America could afford to lose thousands of trucks because American factories could build replacements. America could afford to accept the inefficiency of rolled seam jerry cans because American capacity overwhelmed the losses. The lesson extends beyond containers and convoys into fundamental principles of how institutions function under stress. Institutions optimized for efficiency become brittle under conditions of insufficient capacity. A single jerry can failure, multiplied across thousands of containers, becomes a logistics crisis. A single strategic misjudgment, multiplied across an entire military structure, becomes a catastrophic failure. German institutions, optimized for careful planning and resource conservation, could not absorb the losses of modern mechanized warfare. American institutions, optimized for output and waste acceptance, could absorb enormous losses and continue functioning. The jerry can story and the Red Ball Express story together tell the story of World War II in miniature. Germany created excellence in isolated domains. America created overwhelming capacity across all domains. Excellence in isolation could not overcome capacity applied universally. Germany won every technical comparison. Germany possessed superior design in almost every domain of military equipment. Yet Germany lost because capacity determined outcome, and American capacity was so overwhelming that German superiority in design became irrelevant. The post-war world would be structured around principles learned from the Red Ball Express rather than from German engineering. American military doctrine shifted toward emphasis on logistics and capacity. Allied strategic planning prioritized overwhelming production over technical excellence. The industrial military complex that emerged in post-war America was optimized for exactly what the Red Ball Express had demonstrated. That capacity applied at scale determined outcomes more than design excellence or tactical brilliance. Vinzenz Grunvogel, the engineer who designed the jerry can in 1937, never saw his design adopted as the world standard. The jerry can remained a masterpiece of engineering, copied by British factories, eventually mandated in NATO specifications, still in use 90 years later. But Grunvogel witnessed the complete destruction of Germany while his jerry can, that perfect expression of 1937 engineering excellence, remained unused in quantities sufficient to matter, because German institutions could not generate the capacity to produce them in numbers that would sustain modern warfare. The design was perfect. Germany was defeated. No engineering excellence could overcome strategic failure driven by institutional refusal to acknowledge reality. The 23,000 drivers of the Red Ball Express, most of them African-American soldiers, segregated, discriminated against, denied equal treatment and recognition, proved through their actions what equality of capability required. They drove through exhaustion, through mechanical failure, through weather that stopped armor. They delivered victory not through superior design, but through willingness to work at limits that German doctrine considered impossible. Their victory was a victory for American institutions' capacity to absorb human effort and material resources and apply them at overwhelming scale. The jerry can and the Red Ball Express together represent two different approaches to warfare. One represented German excellence, perfect design, efficient use of resources, meticulous planning, minimal waste. The other represented American pragmatism, flawed design accepted as adequate, wasteful use of unlimited resources, improvisation and decentralization, ruthless pursuit of output. The outcome was determined not by which approach was theoretically superior, but by which approach was compatible with industrial capacity available to each institution. Germany created the perfect jerry can and lost the war. America created an inferior jerry can and won through overwhelming production. American victory was not achieved through American excellence, but through American capacity to overcome American flaws through sheer volume. The lesson: that institutional capacity matters more than technical excellence when resources are unlimited, would shape military thinking for generations after World War II ended. The jerry can remains in military arsenals worldwide, still recognizable as the 1937 German design, still manufactured with welded seams because that is what works. Vinzenz Grunvogel's design outlasted the nation that created it, the war that made it necessary, and the ideologies that shaped the conflict. The perfect design prevailed in specifications and standards, even though the nation that created it was completely defeated. But that design, perfect as it was, came too late to German institutions that needed to embrace it when institutions still existed, capable of implementing it at scale. The Red Ball Express, meanwhile, dissolved as quickly as it had formed. By November 1944, as rail transport restored conventional logistics and the need for continuous convoy operations diminished, the operation was discontinued. Trucks were reassigned, drivers were rotated, routes were returned to civilian use. The massive temporary operation that had required 23,000 men, 6,000 vehicles, and hundreds of installations simply disappeared in 72 hours. Germans required months to create smaller operations and years to dissolve them. Americans built what they needed, used it, discarded it, and built something better. The jerry can and the Red Ball Express together tell the story of how institutions succeed and fail. The story is not about which institution was more innovative or more intelligent. The story is about which institution could generate overwhelming capacity and apply it at scale. Germany possessed superior design. America possessed superior capacity. In the end, capacity determines outcomes in industrial warfare more than any other factor.